Okay, digital design and fabrication, the topic today. For example, we are going to print, okay? Print, not papers, 3D prints, okay? All your subject for the lab exercise number 0 and number 1 is print out your 3D objects based upon your 3D Max modeling. Until next week, okay? So, what to do today listed here. Lab exercise number 0. It is an actual demo and instruction how to use 3D printers for your design visualization. Another type of visualization, physical, actual visualization. So you need to print your own small geometry, not bigger one, okay? For example, you can use lab exercise number 1 today or your table design last time, okay? 2 weeks ago until next week. Also, I'm going to print as an example for the lab exercise number 0 today. Okay, so lab exercise number 1, 2, 3 today all are about architecture model. Architecture model, which means building design, environmental, built environment modeling. The first one is actually something a little bit different, using editable poly and lots of modifiers, frequently used modifiers to transform your geometry into some type of building looking geometry, okay? For example, cutting system, facade system, building skin system in both architectural and non-uniform, organic shaped form. Next one is architecture modeling using external geometry. The first one is SketchUp model from 3D warehouse. The last one is using your AutoCAD plan files. Very frequently used one. That's why I brought this one today's lecture. We are exactly on the middle of the semester. What we have walked through last 8 weeks, including today, that's a remainder. After the same period of time, the end of the class and Christmas, okay? Also, I like to inform you that tomorrow, anyone has lecture tomorrow, 5:30 p.m. class? If you don't have class, you strongly recommended to attend this special guest lecture, okay? For your career development, okay? So, this man from SK Telecom is in charge of headhunting for companies. So you can get some general features of your future job opportunities as well as some type of preparation, what you need to do. Even if you are just second year students, I think that's okay. Just join this special guest lecture tomorrow afternoon, okay? Okay, let's get started. Digital design and fabrication. I simply list up the conventional process of digital design. Your idea, invisible in your head, in your brain. That is why, simply say, it's invisible, okay? No one knows what is your idea. So you need to build your computational models. In this semester, mostly it's 3D Max file, okay? Sometimes CAD model, Revit file, BIM model, sometimes freehand drawing, okay? But actually it's not computer model. It's your design presentation, your hand drawing, diagramming, okay? Anyway, by using computational model, you can visualize your design. You can represent your design in terms of its geometric shape, concept, reference image, and so on. So this is conventional way of design, digital design, okay? Plan drawings, design slide, renderings, videos, all they derived from this computer model, okay? They all the extraction from this computer model. Actually, this is the end of your design in your design studio, usually, okay? But what's next? Actually, our design, any single of your designs supposed to be realized in real world, okay? Realization of design, erecting of your building, actualization of your design, interior design, whatever it is. That's our actually main objective. But frankly, this is of course not the end of the design life cycle. In terms of design life cycle, what's next? Operation, maintenance, management, okay? So that is why we are saying AECFM industry is our industry. Architecture, engineering, construction, and facility management, okay? Anyway, we can complete our design process from your design idea to realization of design. What's next of your design presentation? Of course, it can be installed, constructed, erected on site, okay? But actually there are some more. Shop fabrication, prefabrication, prototyping in a different floor. Sometimes outside of computers, sometimes very stick to computer technologies, and we physically make something, okay? So this part, fabrication, especially focusing on digital fabrication is the topic today, okay? And also we're gonna really print out using 3D printers we have. So let's take a look, case study. A case study at Georgia Tech Digital Building Lab. There is digital fabrication lab, huge building. But that building is in charge of fabrication, prototyping, mock-up making. From Hanyang University, lots of our students went there 2 years ago, and we made some series of those interior design panels. So take a look, those interior design panels, okay? They are something functional, but mostly they are some decoration, okay? Decorative objects, especially on this kind of vertical walls, okay? So take a look. Some wavy surface structure and flower looking and different patternized colors and another pattern. So those things can be designed and fabricated by digital technologies. So here is very simplified plan. Design, fabrication. Very easy and straightforward, exactly what we need to do. But is that enough? Is this enough? Of course not. We need another process when we going to build it in digital technologies, such as 3D printing or some type of CNC control or something. We need to simulate. We need to modify if we find some problems in actual fabrication process, okay? So this one, simulation modification, simply means verification of manufacturability. What is manufacturability? The capability, whether it's manufacturable or not. Another word, constructability, okay? Constructability simply means the capability, whether it's constructable or not. Very straightforward. To simulate actual making process using computers, that's the simulation we need before actual fabrication. Simply because this is not handmade process. This is computer generated fabrication process. So now 3D printer is working on for making something, but it's supposed to be simulated before actual print, actual fabrication, because computer doesn't know what it makes, okay? Only human being operators, users know what it is. So we need to preview real final output before actual printouts. Anyway, we put the term digital in front of design and fabrication. That means we are going to use specific applications. Firstly, for the design, at that time we used Rhino and Grasshopper for geometric modeling, but Actually, you need to use Maya, 3D Max, even SketchUp or Revit, anything you can use for geometric shape making. Facilitated by such applications, you can make any geometric shape, okay? But before fabrication, we need to use some software, at this time, AlphaCam, for simulating physical elements using CNC machine. What if you want to use 3D printer? You need to use 3D printing simulation software. At this time, simplified 3D software. And then your design is supposed to be optimized, okay, modified for the final fabrication. What types of hardware we use? CNC. CNC machine is computer numeric control. There is lots of blades. The saw blades going to cut the wood material, okay, in order to make some specific shape. Water jet is very strong and thin jet stream to cut any material, even metal material, okay? Laser cut, you know what it is, laser cutter, we frequently use that. And also 3D printers, okay? So here is the design, original design model and some manipulated, and this is simulation too. This is the cutter blade, okay? This one is moving around in order to make this geometry. So this is final output of the product. At this time, the material was wood. So take a look, some series of individual groups and their design work. Design concept, some copy of nature shape, so-called nature biomimicry. Biomimicry simply means some bionic or some organic features, geometric shape can be copied to design your things, environment, furniture, whatever, okay? Anyway, some biomimicry approach, concept and algorithm made and the final output. All those are digitally digitally generated images, not real product. And 3 more examples, take a look. Golden ratio, Fibonacci sequence, and Voronoi algorithm, and some nature wave looking lines, something like this. So this is the sort of midterm presentation done by students. This is very conventional design presentation, okay, before construction. After this, some experts in digital fabrication, including me, joined to give them some type of comments in order to realize this design into real, actual, physical design objects. Something like this, okay? So we used AlphaCam software for CNC machine. This is some type of CNC machine deck, and here it is. And here you can see the CNC machine is actually working for cutting the surface based upon designer's design intent. So some series of pictures for the final presentation. All those material outputs digitally fabricated by various machines. Some from CNC machine, some from thermoforming, some for laser cut, some done by 3D printing, and so on, okay? So here, all these are not images, they are all real pictures, okay? Take a look. Group D, some flower-looking geometry. This is CNC machine wood, thermoforming, plastic, CNC machine, laser cutter, CNC machine, and water jet cut plastic, and so on, okay? CNC, thermoforming, laser cutter. How about this one? This is CNC machine generated wood structure, thermoforming, and take a look, concrete mold. We made some design using concrete material. So this one also in my room, in my office, very heavy, But anyway, this one is capable to install real building environment as one part of the building element. Anyway, all these are real pictures and a series of demonstration video for those design. Let me quickly show you the example. Okay, this is CNC machine created, okay, and also laser engraving the text, Hanyang University, Georgia Tech, Department of Interior Architecture Design. Take a look, the surface, okay, on the CNC machine bed, this one placed like this way, and the cutting saw is moving in this way, in this direction, and then the final product can be created something like this. And take a look, another example. You can find out this one, not here. Anyway, laser cut and some type of layered structure using some glue. This one attached like this. Another one, take a look. This is very lightweight plastic, very thin. So how to make it? For making this one, we need this kind of CNC wood first. Very thin and high temperature plastic going to be covered on top of this kind of structure. And then high pressure going to be press this structure, and then we can get this kind of final output structure, okay? Thermoforming. Thermo means thermal, which means sort of high temperature, some about temperature, and forming means anyway form making. So this is the method so-called thermoforming, okay? And another one, this one is looking nice, but as you see, total 6 layers based upon laser cut. I think this is the same one, okay? This is the picture of this one. In the same way, this one CNC machine generate this structure, and thermoforming, very thin plastic. Okay, those two are same design, okay? But this one has its material unique feature, shaped. Take a look, layered, 6 layers, different height. But this one has not this kind of structure. But anyway, this is sort of sunflower looking design for interior design panel. What if you have this kind of panel in front of your bedroom wall or something, or your living room, or some building lobby, something, okay? So this is so-called biomimicry, reflecting the design of sunflower shape, the pattern generated, and this kind of layered shape geometry also has very unique feature. Compared to this one, I think this is looking very different and unique. Okay, those are some examples from what we have done. And let me quickly show you the demonstration video for physical fabrication. Take a look. This is the software named AlphaCam. So this is the blade of the saw machine, CNC machine. And this CNC machine, okay, now just color changed, which means this machine automatically replace this blade with this something thinner one, and then make this process. This is exactly same to the mechanism of 3D printers, okay? Okay, next demonstration video will show you this is the CNC machine, around 200,000 US dollars, okay, year one, okay. Sort of vacuum system is working on this plate, and then the plate is attached on the bed of this CNC machine, and the computer control device is here. XYZ coordinate system displayed. Take a look. Lots of different shape blades and the machine automatically changes the blade in order to cut the wood material, okay? So the machine is working like this, and this is the somewhere in the digital fabrication lab, Georgia Tech, okay? Very spacious and lots of things are there. And nowadays they have robot, large scale robot arm in order to manufacture, install something, okay? Jeff? Okay, third one, the material is fixed in this surface, in this bed, and take a look. This saw is moving and cutting edge first and replace the blade automatically and cut the surface in the sequence in an appropriate manner. Okay, now it's moving out in order to replace blade, okay? So what we need to do is to control the behavior of machine, okay? So this is our geometry, okay? This is your design. What you did on top of your computer application is design this kind of thing. But for this fabrication, what you need to do, you have to control the behavior of machine, cutter or 3D printer. For precise location, moving speed, whether it's up or down, whether it uses material or just moving out, and so on, okay? So controlling this one must be saved in specific file format. That file format is so-called G-code file. G-code file includes lots of those behaviors. Something you didn't working on, okay? You are working on this geometry, but you need to define the behavior of machine. That is the very fundamental thing you need for the digital fabrication. Okay, actually last time I showed you this example, and all you have experienced how to scan object, how to scan your face. So I believe all of you going to submit your geometry today from the last week, okay? Your geometry or your friend's geometry, your precious object, whatever it is, you need to use this kind of sensors, laser scanners, or photogrammetry tools in order to acquire geometry. I showed you this one last time, okay? Physical object, but scanned by pictures, and geometry can be obtained like this way, and you can use in your design. This is one sort of reverse engineering. You can acquire geometry from existing ones, okay? That's exactly what I requested last time for your lab exercise in order to get this kind of different approach, something beyond the 3D Max. Okay, let's get move to 3D printing. A new way of digital fabrication. Why so many people say this is ground shaking? Actually, I introduced this one sometimes, okay? When you were even freshman, I showed you this one before. But specifically, I like to show you why it's sort of ground shaking technology. I think most of you maybe experienced some power of 3D printing. But at this time, I'm going to show you this example. Okay, let's take a look those two separate geometry. So how to make this geometry using 3D Max? I think you can make this geometry in 1 minute, okay, in 3D Max. Cylinder and delete top and bottom surface after converting this one into editable poly. And using FFD, select midpoint and shrinking the size. And then you can get this geometry, okay? How about this one? This one is similar to the lab exercise 1 today. So you need to make something like this today, okay? How to make it? Actually very easy. Just cylindric shape and controlling geometry by using FFD or editable poly, whatever, and some turbo smooth. Anyway, take a look. How to get this one into this structure? Because of the size, it's not possible, okay? We have to cut this structure and place this one inside, and we need to glue, okay? But actually, we have this kind of structure, okay? The geometry is exactly on the center of this geometry, and they do not touch each other because this one actually printed out in this form, in this shape, from bottom to top, okay? So no glue, no cut required. This one is originally made in this form, in this shape. That's my point, okay? Another example, this one is looking kind of bird cage, but actually not. It's sort of non-uniform building facade, okay? But it's too small size. Anyway, how to make this geometry? By using 3D Max modifiers, you can make this in a couple of minutes, I'm sure, okay? Something like this one is your lab exercise 1 topic today, and you need to bring something totally different, your own geometry, like this one, until next week, okay? So anyway, my point here is you can make this geometry in a couple of minutes using 3D Max in lab exercise number 1 today. Anyway, making this kind of geometry, what if you want to make this one by hand? It's not possible, okay? There is no way to cut in this detail. There is no way to attach something in this scale, in this precision, okay, without 3D printing. The hollow inside, but it's very solid structure anyway. Take a look. This object placed outside of this one, and then we can print. But if we place exactly on the center, they do not touch each other, but different radius, and then this one is moving inside. So let me show you demo video for 3D printing. This is fundamental mechanism of 3D printing from bottom to top, okay? Currently it's working like this. So you have to take care of, this is the nature of 3D printing. This is the main characteristics of this type of 3D printing, okay? Let me show you this time-lapse video for making this, okay? This is time-lapse video. Because of the gravity, take a look. Something is looking melting down, okay? Because what? Because of gravity, okay? So you need to take account gravity when you create something like this structure. Anyway, this is the fundamental mechanism that I showed you before. Okay, done. This is the mechanism, the fast track time-lapse video. So as a result, this kind of object is not possible to make without 3D printers. How about this one? I showed you this one before. This 3D chain, one piece, another piece, they never touch each other, okay? That is why this one is combined, collected, chained entirely. But how to make this one without cut and glue? Without 3D printing, it's not easy. It's not possible. So this is why we are saying 3D printer is sort of ground shaking. Next topic, next issue, 3D printing, how to actually print. Okay, today for the lab exercise number 0, I like to show you how to actually print. Very straightforward, very easy, okay? 4 steps. First step, prepare your model using 3D Max, SketchUp, Rhino, Revit, Maya, Blender, anything else. You need to use your own 3D software for preparing your geometry. Whatever it is, anyway, you need to make something, okay, for real print. Next step is export it into OBJ file. OBJ file means one of the file format, which is solid 3D object file or SAT. Some other types, but OBJ file is enough. So exporting OBJ file and open this OBJ file in simulation software. This lab has this application, Simplified 3D software. This is licensed software. The main computer in this room, Simplified 3D licensed version installed. So your computer, you need to make your geometry. And then bring your file, no need to bring, okay? Submit to the main computer under your name folder and open it in the main computer, okay? And simulate. Convert it into G-code file. I'm going to show you physical actual demo today. Anyway, this G-code file can be used in actual 3D printer using SD card, memory card, okay? The 3D printer allows SD memory card. So what you need to do is save your G-code file, not OBJ or MAX file. 3D printer doesn't recognize any other files except G-code file, okay? So this G-code file can be placed in SD card in order to print. That's it. Very easy. Let me show you some more demonstration. Take a look. There is a box, okay? Take a look. This is plate, bed plate, and take a look. Cube box is designed at the front screen. What is this? What is this box? This box is exactly same size of the 3D printer, okay? This is simply imagine that this is the inside of 3D printer, okay? Which means that if your geometry is bigger than this plate, there is no way to print, okay? So your object is supposed to be placed exactly inside of this cube box, okay? And then you can make it. Another thing, your object supposed to be attached on the floor, this bed, okay? And then you can make it from the bottom to top. So take a look. This is too big and it's not good. This one's supposed to be rotated and rescaled like this. Why? What if you want to print this? I told you, you need to take account gravity. So how to make this part without support? Because of gravity, this one is falling down, melting down. There is no way to make something on the air, okay? So what if we simply rotate direction and then we can get accumulated output in this way? That's the point. Your solid 3D geometry file can be imported. You can import, double click, rescale using percentage, okay? You can make that 10% small size and you can rotate 90 degrees on y-axis, x-axis, something like that. And then this is very important button, center and arrange. Click this and then you can make it center arranged like this, okay? Okay, it's much better to show you demonstration, actual demonstration. The first one is 3D chain. Actually, I showed you this actual chain before. This is 3D Max interface to make this one piece and make a layout and export this one into OBJ file and get into the simplified 3D software. I'm going to show you another demonstration. The table design done by Thomas, okay? Take a look. This table design is simple. It doesn't mean that this is the best design, but I like to show you how to print this. 3D Max file, your geometry, and OBJ file exported and imported into this simplified 3D. So how to print? In this shape? No, okay? Take a look. Bottom side, only one side, very thin, one piece is touching. How about this? No. Too many support we need. How about this? Also, it's not good, okay? How about this? I think this is the best way to print out. Because, take a look. In this side, take a look. This orange color things are auto-generated support. After print, you have to remove this one. You can easily remove those support structure, okay? But too many support, waste of material, waste of filament. So if you print this out in this form, take a look. Minimized support, okay? In the morning class, we print this out actually, and I gave this to Thomas. Okay. And this is the simulation application. I'm going to show you this simulation in live demo. Next one, I choose this one and I try to print this out in morning but failed. So I'm going to modify design, modify some scale, and I'm going to try it again. Okay, this is the table design, geometry. Very simple. But if you load into simulation 2, what if you print this out in this form? It's not good. Too many support. How about this? Also not good. Okay, I think this is the best. Okay, just simply upside down. Take a look. In this original form, there are too many support. But if we upside down, and then we can make this geometry in this way, I think. And this is the simulation form. Okay, let me show you live demo, okay? Actually, in the folder today, lab exercise folder, under number 0, you can find out the example. The first one is, let me show you this one, okay? The design of this geometry, okay? There is nothing to do. If I don't want to modify this design, let's use this design. So nothing to do with 3D Max, but in this 3D Max, you have export function, okay? In export, you can choose one of the file format, one of the OBJ or SAT, solid 3D model. I have that file. So this is simplified 3D software, okay? This is simplified 3D software, and I have 2 licenses. One is on my laptop, another one is on the main computer. So until next week, you're allowed to use the main computer for opening this application and load your geometry and simulate, prepare to print. Let me show you. Click import, and there is Baekjihyun table, okay? Take a look. Cannot auto-arrange because it's too big. Why it's too big? Simply because this is in human scale, okay? But I told you this rectangle cube means inside of that 3D printer. It's small. So double click, and you can see the option. The scale is there. How about 7% of the size? It's moving, but you have this one, center and arrange. So let me click this button. Okay, now we have this geometry, okay? This is the bottom plate. But think about this leg structure. What if we print this out in this form? How to make this one on the air? Because of gravity, this one is melting down, okay, falling down. So there is function of auto generation for the support. Take a look, this support. So if you click this and generate support, and then take a look. The orange colored structure here, all they are support. In order to print this out, really. But is this good? I'm not sure. So clear all supports, and let's rotate this one, okay? X direction 90 degree, center and arrange. And if you think this is big, so let's make some smaller size, something like this, okay? And another one we need to do is click create support, angle. Okay, take a look. So because of the angled structure, we need to make this kind of support. After print out, we need to remove support. And then you can see the structure. How about this one? Even if there is gravity, this kind of structure can be probably no problem. That's the determination by this machine, this software, okay? So next thing you need to do is prepare to print. So let me click this. What happened? Actually, this one shows you the simulation result. If you move the mouse like this from start to end, you can see the result like this. Let me play, okay? Let me animate. This is the movement of the nozzle, 3D printer, okay? Layer by layer, take a look, not solid fill, okay? Some honeycomb structure or rectangle shaped structure in order to make this plate strong enough, but not too much material, okay? Something hollow, but something not totally solid. So take a look. Red color means it's movement without material extraction. Anyway, flow material created like this way. And let me move this bar somewhere here. Okay. The legs, inside, take a look inside of the legs. Something filled but not 100%. Another very important thing, take a look. Build time, 37 minutes, okay? Please keep in mind that this simulation tool going to show you how long this one going to take in actual printout. Take a look, 37 minutes. Another one, plastic weight, filament weight, 10 gram, okay? So you need to pay around $2, $2, $3 when this machine is available in our machine lab, okay? Device machine lab. But for this class, until next week, you are free to use this one. But important thing is, careful. This is dangerous thing. Sometimes it's catching fire, okay? And sometimes very bad smell and some bad gas, okay? Simply because it's high temperature melting the plastic filament. So we need to open the doors all the time, okay? Replacing the air and so on. Anyway, this is the simulation. Okay, let me try to print this out, okay? Let me print. So click this icon and then I can save. Copy to the SD memory card. And let me plug this into the 3D printer and navigate file and just simply click print. That's it. Okay. You can cancel while you are seeing something wrong in print. You need to cancel and remove. So this is second try, okay, for Jihan table. So I'm not sure it's working or not. Let's take a look. Okay, this is the exactly what we need to do for actual printout. All you guys here in this room supposed to design anything, such as today's lab exercise number 1, something similar to this thing, or your own text, 3D text, your name, whatever it is, as your souvenir. Anyway, anyhow, bring your prints until next week. That's the lab exercise number 0, okay?